Yes, guys.
Yeah, guys, so we are live on YouTube, okay, and we will wrap up this session by 11 o'clock. Our title of the YouTube stream is SD Software Engineer SD3 Daily Practice.
Okay. So I'm going to explain this topic. Okay.
Yeah,
First, what is priority queue and what is heap and how this heap help us where and which type, in which type of problems. So priority queue is a queue. लाइव है यूट्यूब पे
yeah, this is live on YouTube.
ऐसे भी कोई देख तो रहा नहीं
Yeah, nobody is watching this.
एक मिनट मच्छरदानी लगा देता हूँ सो रहे हैं इनको नींद नहीं
Okay, fine.
लाइव यूट्यूब पर मच्छरदानी लगेगा
Hey guys, this is Garam Masala. This is my soap, and this is Garam Masala. If you want to buy it, buy from Sri Ram Mega Store at Jani D. Ghoga. And I am Ritesh Kumar, and I'm currently building my application just like Blinkit, similar to that. And we are on track, and I have already applied on the Google Play, and also we have got everything done, and we are in testing phase, in a closed testing phase, and many of us are testing it. I've already 5 of the testers I've included. I need almost 10 testers more so that we can complete the testing for continuous of 14 days. And then we will apply for the production access and it will be live. Okay. And you can download it from the Play Store and you can take enjoy shopping from your home. Okay, without waiting in the queue at the shop. You can just order it from the shop. Your shop will, whenever it will be ready, your item will be packed and you will be sent a notification that your item is packed and you will no longer need to wait. You just need to get down to the shop and pick up your orders, which will be ready for you, waiting for you. So that's all about my application.
yes guys so let's continue
Yeah, by the time you were busy with your Machadani, I
yes mosquito net
yeah, yeah. I I marketed my application.
okay good job bro but you have to let's start with the priority queue in normal queue we follow FIFO order first in first out but in priority queue we don't remove elements just the based on the insertion order but we remove the element based on their priority and which define the priority we define the priority one of the most confusion people get confused in like in priority queue elements are sorted in some particular order but that is not true only one most only one element will be at the correct position like in min heap minimum element will be at the top which is ready to pull and in max heap maximum element will be at the top by default we get the min heap we can make
No,
it
I
max
think
heap
I
also
think it's not sorted, but there is order. Means it is ordered in the way that it forms a structure of a tree. Okay. If you keep
Yes.
on polling and polling, your suppose you have a mean heap is something like all of the elements will be at the left first, all the smaller element and bigger elements at the right. This is the, I think, basic logic of mean heap. Huh?
Okay. Yes. You are right.
So it will be ordered in the same way in the application. If you keep on polling in the priority queue, you will get in the same order. Okay. Which will be in the
Yes.
tree.
If you are removing that one element, then again the most maximum element will come at the top in maximum.
Yeah.
If we'll keep falling, maximum element will keep shifting at the top, and it use internally heap tree
Yeah.
to make this thing possible. So there is no sorting first thing, and only one element are at the top. So how it help and in which type of problem it help us? We are not going to implement tray for this maxip or min. Okay, we have already given data structure priority queue using which we can create maxip or min. Whenever your requirement is sorting, okay, let's take this element, this one also, or any element. So let's go to the notepad. So I have to give k most frequent element. So first I have to count the frequency of the all the element, and then I have to sort. Okay, that map based on the value, and I have to give return the k most frequent. Am I right?
Mm. Yeah.
So I have to do this thing. So wherever there is a requirement of sorting and returning the k element or kth element, the smallest kth element, or largest kth element, then we are going to use heap. And how it helps? First thing, if you are going to sort any array, the time complexity is going to be n log n. Okay,
Yeah.
so n log n, like merge sort. So whenever you are going to do any sorting, but if we have already sorted, so how this heap will help? In heap, instead of sorting all the n element, I will sort only the k element. Are you getting my point?
Yes.
Like I have 7, 12, 8, 15. Okay, let's take 120 also. I just want, okay, take 9. I want third smallest element. My requirement is third smallest element. So which is the third smallest element? 3 is the 7 is the third smallest element. First, what will I do? I will sort. Okay. How will I sort? 7, 8, 9, 12, 15, and 20. So I have sorted. Now I want, let's say, I want third smallest element. So our third smallest element is 9. Okay. So why I have sorted these elements also? Is this required? Not required. How it will help in heap? Heap, just understand, just keep in your mind, heap is like a stack initially. Okay. So like I have first put the 9. Okay. I put the 9. Now next element is 7. So I have to find kth smallest element. So whenever you have to find the smallest element, I will take the maximum. And whenever I have to find the largest element, I will going to take min. Why we are going to do? You will understand why I am explaining this question. So this is 9. Next element is 7. So just consider 7 is coming below 9. And this is the max shift. So maximum element will be always the top. Okay, there is only one surety. This 9 is always at the top. The maximum among all the elements will be at the top. Okay, now I have 12. So 12 is going to be here. Next is 8. So 8 will come somewhere, anywhere, but below 12. Okay, now see, the size is, I want third, k is equal to 3. Now size is 4. So this 12 never going to be the part of my answer. Is this 12 going to be the part of my answer?
Yes.
No.
Kth is smallest element. No.
I want kth smallest element.
Mm.
So I have already 3 elements smaller than this 12. So 12 is never going to be the part of my answer. So I am going to
Yes.
remove this 12. Okay, now I have 15. I have added 15 here. Again, my k is 3. So this is more, the size of heap is more than k. I have again removed this 15. Next is 20. I have removed the 20 also. So my
Yes.
size of my heap was never be greater than k.
Yeah.
So just sorting k element, in order to sort k element, we need n log k instead of n log n.
Mm.
So how it helped you? Did you understand?
Mm.
This is why we use heap instead of normal sorting and iterating that number.
Okay.
Okay, and I will remove all the maximum elements from the top when we are we are searching for the smallest element. When we are searching for largest element, we'll create the main heap and we'll remove all the minimum element from the top and we'll find our answer at the bottom. Do you understand why in
Yeah.
case of
Yeah.
the smallest element I took the max heap, in case of largest element I took the min heap. I have did same thing here. I have to find kth most frequent element. So for kth most frequent element, first I have searched the frequency. In priority queue, inside the constructor, I have given the object of inside the constructor, I have given the object of comparator. The comparator is sorting in a natural sorting order. Why natural sorting order? It is going to create mean heap because I am finding the largest, most frequent, largest. Okay, not least frequent. I am finding what most frequent. That's why I need mean heap. In mean heap, I have given this constructor and this comparator object a
Mm.
comma b map dot get a minus map dot get b. So on the based on value, it will keep most frequent element, least frequent element at the top always. It will keep least frequent element at the top always. I will keep removing the least frequent element so that my time complexity will be n log k instead of n log n. So then I have set all the keys inside here. It has already sorted based on the value. Whenever my size of my min heap is getting greater than the size k, I am keep pulling. I am keep removing the elements which frequency is minimum.
Yes.
Okay. Now in the result, I have simply iterated the min heap, saving the result, and I have solved. So this is one approach of solving problem with the help of min heap. You can go ahead and explain something.
So in a priority queue, since uh, we solved some problems like where we have to find a fixed size of element, uh, okay, like getting the three most frequent element, okay, or a chain for most frequent elements. So we define the heap size in this problem so that only we have to order the elements uh, of the kth size only. Okay. So using priority queue, which stores the element in a tree order internally, uh, we have two types of heap. One is maximum and one is minimum heap. So to solve this problem, since we have to find the most frequent element and we have to always remove from the priority queue the least frequent element. Okay, so we have to use the minimum heap here because that will be at the top, and we will remove the topmost element from here, from the priority queue. So that's why we will use here a priority queue with our custom logic, that is a custom logic of the frequency of all the element. That priority queue, we will use a comparator which will based on the which will keep where priority queue will keep the frequency of all the elements. Okay, and based on that, we will store all the elements in the priority queue in the first step. And then in the second step, we will just try to, uh, since we have already defined the queue, we already know the how many size of the uh, frequent element we need. So based on that, we will try to in the heap, we will try to add all the elements from the we will try to add all the elements from the map and keep polling other elements if our heap sizes increases, because heap will always maintain a order that the least frequent element will be at the top. Okay, and then
Yes.
in the next our heap will at the last our heap will be storing our result finally, and we can from that we can get our result in a array, and we can return that as required by the person.
Okay, understand.
Oh,
So is it enough for today?
yeah. This is enough for today. Let's
Okay,
meet
guys.
tomorrow. Okay.
Okay. Will I start tomorrow? If it,